Hi, we now turn our attention to the equation of a line. Specifically, what we want to do is see how we can determine the equation of a line given 2 points. So, by way of review, let's take a look at this equation here, y equal 5x plus 2. What this is telling us is that we have a line whose gradient is 5 and which cuts the y-axis at 2. So the y-intercept is 2 and the gradient is 5. The general form of linear equations is y equal mx plus c, where m then is the gradient and c is the y-intercept. Only one unique line can pass through two given points. So for example, in this case we have the point 511 and 1731. There is only one line that can pass through those 2 points, and we want to find the equation of that line. So the strategy is to imagine a third point, some p, placed someplace along this line. Be placed here, between these 2 points, or over here. So I tend to prefer to place this arbitrary point somewhere between A and B. So it's arbitrary in the sense that I'm not specifying any particular values for x and y. I'm just saying it's some x and some y. And the only requirement that these values have to meet is that then the point must end up on this line. And so that's what we're saying here, that this point P is on this line somewhere. So this gives us now 3 little line segments here. Notice we have the line segment AP, we have the line segment AB, and we have the line segment PB. And these 3 line segments share the same gradient. So we can make use of this fact. Actually, we only need to use 2 line segments. We will say that the line segment AB has a gradient equal to that of the line segment AP. So the gradient of the line segment AB is the change in the y, 31 minus 11, divided by the change in the x, 17 minus 5. And the gradient of the line segment AP, well, it's the change in the y, so y minus 11, whatever this y value is, and x minus 5, whatever that x value is. So some basic simplification then gives us this equation, which technically is the equation of the line. But let's transform it so it looks somewhat more familiar. So here we have the equation we just got. If we multiply both sides by x minus 5 and 3, we end up with this expression here, this equation. Sometimes students learn this as cross multiplying, and that's quite okay, I guess. And so then we simply expand both sides, 5x, 5 times 5, and so on. And it should be easy for you to see how we get 5x minus 3y equal minus 8. And so this then is the equation of the line in standard form. So this line passing through these 2 given points corresponds with this equation. And we can check it by simply placing these points in the equation. So if we place 5 and 11 here, we should get minus 8. So check it. If we place 17 and 31 where the x and y values go, we should get minus 8. So check it and you'll see that indeed it works out. Now we have this equation in standard form. Let's express it in the slope-intercept form. So this is where we left off, in standard form, and it should not be hard for you to make y the subject of this expression, of this formula. So if you make y the subject of the formula, you get 5/3 x plus 8/3. So if you have some difficulty with this, you need to review how to make any particular variable the subject of an equation. You can check by placing 5 here and you should get 11. Place 17 here and you should get 31. Okay, so I think this should be clear enough. Let's look at an example. In this example, we're asked to find the equation of the line passing through these 2 points, minus 3050 and 4020. So let's begin by sketching our x and y axis and more or less placing where these points belong. So minus 3050 plausibly could be somewhere around here. Likewise 4020 around here. We then draw our line that runs between these 2 points. It's the equation of this line that we want to get. We place an arbitrary point on this line and then we just write in the coordinates. So this point is arbitrary, so it has coordinates x, y. So this is the point 4020, this is the point minus 3050. To avoid confusion, let's name these. Let's call this point A, this point P, and this point B. And so these 3 line segments, remember, share the same gradient. Therefore, we can say that the gradient of AB, that's from this point to this point, is equal to the gradient of the segment PB. And so the gradient of the line segment AB is the change in the y, which is 20 minus 50, divided by the change in the x, which is 40 minus a negative 30. The gradient of the line segment PB is the change in the y, which is 20 minus y, over the change in the x, which is 40 minus x. And then we simply simplify. This comes out being minus 30 over 70, which can be simplified to 3 over 7 minus 3 over 7. And so this essentially is the equation of the line. However, let's first bring this to standard form and then to slope-intercept form. So this is where we left off. We simply multiply both sides by 40 minus x and 7. That leaves us with this. We expand, we get this, and it should be fairly easy for you to see that we end up with 3x plus 7y equal to 260. So this is the standard form of the equation of the line that passes through these 2 points. Now if you want this in slope-intercept form, we simply make y the subject of the equation. So then that gives us minus 3 over 7x. The nice thing about this form is that you can see immediately what the gradient of the line is. It's minus 3 over 7, or approximately minus 0.43. And it cuts the y-axis at 260 over 7, or approximately 37.14. So make sure you practice finding the equation of the line passing through a pair of points. This is a very important skill. Thanks for looking at this video. Bye for now.